Hello, this is Orlando Castilleja. Welcome to a new tutorial on the use of the flow simulation add-in in SolidWorks. In this time, we want you to learn about how to create rotating wall boundary conditions. The main problem is to simulate a long sprinkler system specifying rotating wall boundary conditions. We want to achieve three main objectives. The first one is to use the swept boss base feature to create geometries in SolidWorks. Then we want to specify moving wall boundary conditions. And finally, we want to generate surface plots in the flow simulation add-in. The problem we're going to be working with in this time is specified in this slide. I think that you have already gone through this problem in your class of fluid mechanics, but now we want to show you how to specify the basics of this geometry in SolidWorks. In this plot, in this graphic, you have some specifications for this model. We know that we have an inlet, and the inlet has a flow rate of 16 gallons per minute. We will feature two outlets here, and we can use the flow simulation add-in to determine some properties or parameters here. We know that the nozzle exit area is 0.04 square inches, so we need to determine firstly here the radius of this circle. We also know that the radius of the nozzles, the total length of the nozzles are 8 inches, and we also are going to use as a first approach the value of the revolutions of this head. We will take this value of 500 revolutions per minute to generate some results in this case. We are going to generate this geometry departing from a 2D sketch for the main body of this sprinkler, and then we're going to generate the two nozzles. We're going to create an animation like this one, and in this case I'm plotting here the velocity field. Remember that you can always go to the technical reference document if you want to know more about the equations that are being solved in this simulation. You can follow the route here in your computer. If you have the software installed in your computer, you can follow this route and obtain this technical reference document. Okay, I'm going to move on to the SolidWorks main window. Okay, now we are here in the SolidWorks window, so I'm going to select a new part. Okay, to begin with our sketch, I'm going to select the front plane and select sketch. I'm going to draw a center line or a construction line, and I will begin from the reference point. Okay, there you go. I'm going to select again the construction line that I just draw, and I'm going to define that is of infinite length. Okay. I'm going to begin with my sketch, and I'm going to select a solid line here, and I will depart from the origin. Make sure that you highlight the origin and you start to draw from over there. Okay. At this time, it's not necessary to worry about the actual length. Okay, you have a shape like this one, something like a flask, and now I'm going to define the length. Make sure you are working on the unit system you prefer. For example, here I will select millimeter, but actually we will work on both millimeters and inches. So I'm going to select Smart Dimension, and here I will define that I have 100 millimeters in length. Okay, for this part the radius will be 25 divided by 2 millimeters. For the bottom of this geometry, we will have a value of 25 millimeters. Okay, I think that I'm forgetting about something. What I should do here to prevent the construction line from moving from the reference point, I will have to add a relation. So I will select this construction line, and I will go to the sketch ribbon and select add relation. So I will also select the origin. So in the selected entity section, I have line 1 and point 6. So I will make them coincident here. So this will prevent the construction line from move from this reference point. Okay, I'm going to click OK. Now I will define this. That this part has a length of half an inch, and these two. Okay, there you go. Now we have a fully defined sketch, and now we can proceed with the revolution of this shape to obtain a 3D geometry. So to do this, we're going here to the features ribbon, and I'm going to select revolve boss base. The message says that this sketch is open because of this section with a construction line. So I will select no here, and I'm going to the theme feature section, and I'm going to define that we only have a value of 1 millimeter for thickness. This value is enough, and I'm going okay, the axis of revolution is already selected, but if you don't have it selected, you can only click in this part and select the line. I'm going to click OK. So now we have this geometry. Okay, I'm going to position again on the front plane because we want to draw a pipe for the inlet. Okay, something like this. We need a pipe here, and we need a pipe for the nozzle, for the outlet nozzles. Okay, to begin with the inlet pipe, I will position on the front plane, and I will start a new sketch, and I'm going to select from the sketch ribbon the circle, and I'm going to position here. Okay, I think that the diameter in this case, it can be 0.25 inches. You can define here the units you want to use, and the distance from this line to the center of the circle will be also 0.25 inches. Okay, there you go. If you rotate the figure, we notice that the circle is sketched in the middle of the geometry. Now we have to use operation, extruded boss base operation. I will click here, and from the list I will select offset, and maybe I can use 2 inches in the value. Okay, and direction 1 section I will select up to surface, and I will select this surface. There you go. I think 2 inches is enough for this pipe, and I'm going to select thin feature to make it a hollow in the center. So here I will define a thickness of 1 millimeter. I think it's enough, and that's okay. Click OK. There you go. I'm gonna use the view section here. I'm going to change the direction. Okay, here you can see that we don't have an orifice here in this side. So what we have to do is to use the operation extruded cut. So I'm gonna deactivate the section view. So I'm going to select this sketch. It is already highlighted, the circle here. So I'm going to select extruded cut. I'm gonna flip the orientation, the direction, and I'm going to select up to next. Okay, and I think that we have already created the hole here. To make sure about this, go to section view and click OK. Okay, there you have. So now we have to create the nozzles in the top section. To do this, we're going to position on the right plane, and I'm going to click sketch. And for this sketch, I'm going to select the circle, and I'm going to position here. So there you go. And I'm going to select, define that the distance from the top to the center of the circle is 0.25 inches. Okay, there you have. So the problem defines that the area for the nozzle exit has a value of 0.004 square inches. So if you want to define the radius, you have to calculate it, and we have calculated a value in this case in this way: 0.11284 inches. Well, in this case we have to define the diameter, so it is multiplied by 2. There you have. Okay, close dialog. Now you can see the circle highlighted in this way, and we're going to extrude one of the nozzles. Okay, you can also remember that here the radius of the pipes is 8 inches. So what I'm going to do here is to draw or to extrude a pipe with a length of 7 inches, and then I'm going to draw this section. The same for the other nozzle. So here I'm going to select features and extruded boss base. Okay, firstly I'm going to select thin feature because sometimes you can forget about it, and the thickness in this part also will be 1 millimeter. From the from list you will select offset, and you will define 7 inch, and in direction 1 list you will select up to surface, and we'll select this surface. Okay, I think that's okay, and click OK. What we have to do here again is to select the section view, and you can see that you also have to make an orifice here. So I'm going to use the extruded cut function. I'm going to deactivate the section view, and I'm gonna position on the sketch 3. The circle is already highlighted, so I'm going to select extruded cut, and here I'm going to select up to next, and I'm going to flip, to change the direction here. There you go. Now you just have to click OK, and the operation is complete. If you want to make sure, click section view. Okay, there you have. Next. Okay, I'm gonna deactivate the section view, and I think I can position again here in sketch 3, and I'm going to extrude a new pipe. Here features, extruded boss base, and I'm going to select from offset and 7 inch. From the direction 1 list, I'm going to select up to surface, and again you will select this surface. If you want to change the direction of this operation, you can click here and here, and remember to activate the thin feature. The thickness is already set as 1 millimeter. Now there you go. Of course you want to make sure again that you have the orifice created here. No. So what we have to do is to position here again to highlight the sketch number 3 and click extruded cut. From direction 1 list you will select up to next and click OK. There you go. I'm going to deactivate the section view. So we need to create these bends, and to complete also this this length because we have already created 7 inch, so we need an additional inch. To do this, I'm going to create a plane, a new plane, and I'm going to the features menu, and from reference geometry I'm going to select plane. As a first reference, I'm going to select this surface, and I'm going to define here that I want a distance of 0.25 inch, and I'm going to change the direction of this plane, okay, or the position of this plane. In this way, I'm already positioned on the center of the circle I created here before. So in this way, I will be able to start a new sketch from here. So I'm going to define here a line, and I'm going to start from the center of this geometry. Make sure that you highlight the center, this reference point, and start drawing from here. Okay, I'm gonna draw a first line here, and then a second line downwards. There you go. I'm going to define that the length for these lines is 1 inch, and for this one also as 1 inch. Okay, to feature a bend, I'm going to select here a sketch fillet, and I can select this point, and I will define that we have a radius of 0.5 inch. Okay, there you have. The objective of drawing this line is to select here the swept boss base feature. You are going to the features ribbon, select swept boss base, and here you need to define what is the profile that you want to extrude. For example, in this case you have to select this circle, and the trajectory will be this line. And remember to activate thin feature here. And now you have selected, well, by default you have 1 millimeter. Okay, and now you just click OK. Now for the other side you have to do exactly the same. So I'm going to position here in the plane 1, and I will start a new sketch. I'm going to zoom in here, and I will select again a line. Remember, you have to highlight the reference point here. I start drawing the sketch. You just need 2 lines, and the dimensions of these lines will be 1 inch and also 1 inch. You will create a sketch fillet here, and the value is 0.5 for the radius. Okay. Okay, and I'm going again to the features menu, swept boss base, and I will select this circle and this line. Remember to activate thin feature, and you already have the value you need, 1 millimeter in thickness. Click OK, Okay, I think that the geometry is already complete. I'm going to save it before anything else. Okay. There you go. We already have this geometry. We have an inlet and two outlets. And what we need to do now is to go to the flow simulation component of SolidWorks. And to do that, you can go here to, well, you can go to the SolidWorks add-in, and you could select this one. This one, SolidWorks Flow Simulation. Also, you can go to the options menu. You will select add-in, and you have to activate one of these checkboxes. Here you have SolidWorks Flow Simulation, and you can activate it in this part. And if you want it to be activated for every time you open SolidWorks, you can select also Start Up here. Okay, I'm going to the Flow Simulation ribbon, and I have to create some leads for the software to define the best computational domain for this geometry. It has to be closed, so I will select Tools and Create Leads. I will select this surface for the software to create the lead. Also this, and I'm going to the other side and we'll select this part. Okay, that's everything you need to select, and click OK. Okay, as you notice, you have already created the leads. And now we can proceed to define our flow simulation model. To do this, I'm going here to the flow simulation ribbon, and I'm going to select Wizard. In project name, you can type sprinkler. Everything else is okay, and click next. In this window, you can select the unit system you want to work with. And in the second section, you can change the number of decimals you want to show your results. The number of decimals you want to show your results with. So I will click next. In this third window, you have to select what kind of analysis you are working with, and this is an internal type of analysis. So you can also select here in this section that if you want to activate or consider the gravity for this model. So in this case, I want the acceleration of gravity to act on the Y component, and I'm going to type 0 for the Z component. Okay, I'm going to click next, and in this window I will have to select what is the working fluid. In this case is water, so I will expand this tab for liquids, and I will select water. I will click add, and in the flow type you can select from laminar and turbulent, or only laminar, only turbulent. I will set it as default, and I will click next. And in this last window you can select the roughness or define the roughness of the material, but in this case it's not necessary. I will click next, and in this final window you can define what are the reference thermodynamic parameters, for example for the pressure and the temperature. I think it's okay. The reference pressure is 1 atmosphere and the temperature is 2093.2 Kelvin. I'm going to click finish, and as you notice the computational domain is already highlighted here. If you want to deactivate it, well, not deactivate it but hide it, you can hide it here. You right click on computational domain and you can show it again. What we need to do now is to define the boundary conditions. So we're going to position here on the boundary condition section, but first I think that we should review what are the units that we should be using. Here, for example, for the inlet, the flow rate is given as 16 gallons per minute, and we also know that the angular velocity for this head is 500 revolutions per minute. So we're going to make sure that we are working with the appropriate units. Of course, you can always do your conversions by your own, but if you don't want to do that, you can go here to input data and right click on it, select units. Okay, we're going to loads and motion section, and here you can find the angular velocity, for example, and you have radians per second. If you want to give this value as rotations per minute or revolutions per minute, you can select this one. Also for the volume flow rate, you notice that you have cubic meters per second. If you want to give it this value as gallons per minute, you can also do this, gallons per minute, use gallons per minute. Okay, that's okay. Now we're going to position here boundary conditions. I'm going to right click on this node and I will select insert boundary condition. Okay, here I will have to select the type of boundary condition. Of course, this is a flow opening for the inlet, and I will select inlet volume flow. As you notice here, we already have gallons per minute, and it will be easier for us to define that we have 16 gallons per minute. So the inlet boundary the inlet boundary that I will select will be this one, and I will have to right click on it, but remember that your boundary will have to coincide with the computational domain. To be sure that the boundary you select coincides with the computational domain, we'll right click on this boundary and we'll select other. And in this case, I will have to select that is the lead number one, lead one. Okay, there you go. Okay, I think everything is okay here, so I will click OK. Okay, I think it's not right. I'm going to clear the selection, and I will right click here, select other, face lead 1. Okay, let me check if this is right. Okay, it's right. Well, now we have to define which are the outlet boundary conditions. In this case, I will have to select another type, that is pressure openings, and you will have to select environment pressure, that is selected by default. So the outlet will be these ones, this one here, and I'm going to create another boundary condition for the other side of the another outlet boundary condition here. Okay, there you go. Now we have defined the outlet, and the next step is to define the moving wall conditions. In this case, I will have to go here to boundary condition, insert boundary condition, and a new type of boundary will be this one, wall. Okay, I will select this one, real wall, and I will activate that we have wall motion. Okay, here in the axis section, the axis list, you will have to select the axis about the one the walls are moving or rotating. So if you notice here also, you can see that the units for revolution per minute are already shown, and I just have to type here 500. Okay, I have to select which are the surfaces or the boundaries that are applied to this boundary. So this one will be one of them, but the inner one, the surface in the inner section. So I will right click, will select other, and I will select face, this one. It is already highlighted. So I will also select this elbow and this section. There you go, and I will do the same for the other side. There you go. Okay, I think everything is okay. I will click OK. So this section is not moving, so I will not have to do anything with it. If I want, I can define that it's a wall that is not moving, but here this head is also moving, so I will have to create another boundary condition, wall type, and wall motion. Okay, remember here you have to change the axis about the one is rotating, the material, and you have to select this face. Okay, again I will have to select. Okay, here I'm changing, or the software is changing the reference. So I will have to select here again an axis X. Okay, so here the value is also 500. Okay, and I will create another one for this section, for this wall. Okay, here I will define 500 revolutions per minute, and I will select that the axis is Y. Okay, I think everything is okay. There you go. So now we have the inlet, the outlet, and the moving walls boundary conditions. What we have to do now is to go to the global mesh. You can double click here, global mesh, and automatically you will see that the mesh is set to a level of 3. You can show the basic mesh here in this checkbox, and I think that it will be necessary to refine the mesh a little bit. So I think that a level of 6 is enough for this model. And now you only have to click OK. Okay, I think everything is okay. I'm just going to verify that the axis of revolution is everything is okay, because sometimes you can forget about it. This is Y, this is X. It changed, but it's okay. And revolve 6. Okay, very good. So now we just have to run the simulation, and I'm going to click here in the flow simulation ribbon, and you locate the run button. So I'm going to run the simulation. A new calculation is okay, and run. Okay, now you just have to wait for the software to finish the simulation. It may take a little bit depending on your resources or your computer resources. Okay, the calculation is already finished, and I'm going here to the results section. I'm going to expand this tab, and what I want to do firstly is to create a flow trajectories plot. To do this, I'm going to position on this node, and I'm going to right click on it. In this case, I will have to select a starting point, and I will be the inlet boundary condition, well, the inlet here, and I will have to define the number of elements that I want the plot to show. Here will be, I think that 100 is okay. And here, for example, you can select the parameter you want to plot. It will be the velocity, and you can have a preview here. Okay, there you go. So I'm going to click OK. And if I want to create an animation of this plot, I would right click in flow trajectories node and play. And there you have. So for example, we can see that in the main body of this sprinkler, the velocity is almost 0, but obviously you get some velocity here at the outlet or the at the nozzles. You can change the visualization you have or the parameter you are plotting here, and you can select here the velocity name, and you can change it to pressure. You can also visualize here the change or the difference in pressure between the main body of the sprinkler and the nozzles. Okay, I'm going to stop this animation, and I'm going to hide all. Okay, now if you want to make sure that the velocity for the material section or the material parts of this sprinkler, I'm going to here surface plot, and I'm going to insert a new one. So I want to know what is the velocity of this section of this wall. Of course, I'm expecting to be 0 because I didn't specify any boundary condition for this part. So I'm going to right click on it and select other. I'm going to select this one. Okay, I'm going to clear the selection again. Okay, there you have. So I want to show what is the velocity here, and okay, as we expected, the velocity of this surface is 0. And now I will create another one, but now I will select these walls. Okay, now the other side. There you go. Here I'm going to plot the velocity, but here I can select that I want to show 50 contours and click OK. Okay, there you have. You have a slight difference in velocity at the outer part of the nozzles respect to the center part. Okay, this is for the velocity of the walls. I'm going to hide all. And now we're getting some information about the inlets and the outlets. For example, here we specified that the inlet condition for the volumetric flow rate was 16 gallons per minute. So maybe I want to know what is the value in mass flow rate, the value of the mass flow rate. So I'm going to position here on surface parameters. I'm going to insert a new one and we'll select this inlet. So I want to know what is the mass flow rate here. Maybe also, maybe I want to know what is the velocity here and the pressure. Remember that we had used the volume flow rate here. I'm going to show it also. And you can also know what is the surface area in this case and show. Okay, now we have a table of these parameters or these variables, and we have values for the minimum, maximum, and the average value. For example, the pressure, here we have a value of 500,000, a velocity of 31 meters per second. The mass flow rate here is almost 1 kilogram per second, and the surface area is 3.1 to the minus by 10 to the minus 5. Okay, we're going to do the same for the outlets now. I'm going to the surface parameters, right click on it and insert. I will select this face and I will select the mass flow rate, the pressure. Well, the pressure, we already know the pressure because we selected atmospheric pressure. The velocity here, maybe the volume flow rate. Also the surface area. Okay, I'm going to click show. Okay, here we have the information that is shown in this table and also on this table, and as you notice here we almost have the atmospheric pressure, and here we have velocity of almost 20 meters per second. The mass flow rate is 0.5 kilograms per second, and the volume flow rate is equal to 7.9 gallons per minute. Okay. We could expect that the values for the other side to be almost similar or almost the same. I'm going to right click here, and now I will select the other side. Okay, I'm going to select mass flow rate, velocity, volume flow rate. Well, volume flow rate is okay, and the surface area. I'll select pressure. Okay, I'm going to click show, and here we have the information. If you notice, almost half of the inlet material is going through each of these nozzles. Here we have an information that we have mass flow rate of 0.5053, and the volume flow rate is equal to 8.0291. Okay, the velocity, the average velocity here is almost 20 meters per second, and the pressure is equal to 101,000. Okay, there you go. Okay, I expect that this tutorial is useful for you and that you can apply the knowledge you acquire here in any of your projects or your class on fluid mechanics. If you have any other question, you can send me a message and I will try to respond to all of your questions. Stay healthy, stay safe, and I expect to see you in our next tutorial. Goodbye.